All right. Pair deck code today is SSYIJV. But if you would also, oh no, I broke that rubber band. Okay. So for bell work today, given this right triangle with an angle of 30 degrees and a right angle and a length of 10 for this side, find the value of C and D. I'll give you 3 minutes to try it, and then we'll go over it. Okay. Let's go over this. So again, there are 3 steps to solving these problems. The first step is to identify what type of triangle we're talking about. Is this a 30, 60, 90? A 45, 45, 90? Or neither? What do you think? 30, 60, 90. All right, it's got that 30-degree angle right here, which means since these 3 angles have to add up to 180, this one would have to be 60. All right, so then I find 30, 60, 90 triangles in my notes, which is 6.3. So then I go to 6.3 in my notes, and I find the picture of the 30, 60, 90 triangle, and then I label. All right, so can anyone tell me which of these is the short leg The side, yeah, C. Yeah, you're very good. Oh, let's rewrite that. C. That is the short leg. Why is that the short leg? And you might be tempted to say it just looks like it, right? If you look at it, that's the smallest side. That's fine if this is drawn to scale. A better answer would be is because it's opposite the short angle. That's why it's the short leg. Because they'll trick you with that on the ACT when they don't draw images to scale. It might look like it's the short one, but really it's because it's opposite the 30 degrees. And if it was drawn to scale, it would be. All right. That means that D has to be the long leg, right? Because it's opposite the 60 degrees. And that would mean that 10 is the hypotenuse. Again, which makes sense because it's opposite the 90-degree angle. Okay, now that I have my labels done properly, my third step and final step is to use my formulas, which again, really you could only use if you have those formulas written in your notes. So for this problem, they give me the hypotenuse. So the first formula I would have to use is the one that has hypotenuse in it. Right, you should have two formulas in your notes, but we can't use the other one because the other one is about the short leg and the long leg, and I don't know either of them. I do know the hypotenuse, so I can use that formula. Hypotenuse is equal to the short leg times 2. If I plug in then, the hypotenuse is 10, and the short leg is C. All right, what do I do next? Divide by 2. I want to get C by itself, right? My goal is to find the value of C. So to get C by itself, I'm going to divide by 2. That way the 2's will cancel, and I'll get 10 divided by 2 is 5. All right, I'm not done yet. I also need to find the value of D. So now I can use that second formula, which told me that the long leg is equal to the short leg times the square root of 3. And so if I plug in my values, the long leg is D, the short leg is C, but I now know what C is, right? C is 5 times the square root of 3. And that's done. Don't do anything more to that. That is a simplified answer. If you actually multiply those out, you will get a decimal as your answer. And now you're taking something that was exactly right and making it approximately right, which is worse, right? It's better to be exact. I have to say, I feel, okay, I don't brag very often, right? You probably have heard as you talk to other teachers at this school and other students, Mr. Lake is the most humble teacher at Topeka West. He could beat any other teacher in a humble competition, just soundly. It wouldn't even be a contest. It'd be like 3 seconds, they're down. Okay. So I don't like to brag, but I feel like I've done a pretty good job of explaining this year as compared to previous years. Usually this is like the hardest thing. I actually think we're doing worse on like the simplified radicals of the Pythagorean theorem this year. Maybe that's just my own perception, but I feel like this isn't as bad. Whereas previous years, they were like, oh, Mr. Lake, this is honors geometry stuff. How can I do it? I think this is doable. But really, the only thing that makes it doable is to have these notes, the 6.3 notes. So if you don't have that, they're in the Google Classroom. Get it. And I think you'll be able. Hey, Mr. Smith. No, she is attending. Oh, wait, hold on. No. Yeah, she's here. Yeah. Will do. I just don't let me forget. So let you out a few minutes early so you can go to the library and swap out your Chromebooks. Because I'll forget. Don't let me forget. All right. Any questions on the bell work? Any complaints? All right. Key thing again is you got to have the notes. Got to have the notes. Without the notes, this problem is impossible. Right? You're not going to know that these are the labels you're supposed to use. You're not going to know, what the formulas are. So, yay notes. All right. Today is going to be another one of those times. 6.4, we're now going to do very similar problems to the one we just did. We're going to have a new set of labels and then a new set of formulas. So I will stress again, these problems we're going to do are very doable. They are, I think, something that you will not struggle with, but only if you have the notes. If you don't have the notes, these problems will be impossible. You will not be able to intuit or look at the picture and, figure out on your own what you're supposed to do. Okay. So you don't necessarily need this in your notes. This is just an explanation. What you really need in your notes is this and this. That's absolutely critical to have down on a sheet of paper, or if you're taking notes digitally in a Google Doc that you can refer to. But the idea here is we found that there are special ratios between 30, 60, 90 and 45, 45, 90 triangles, right? Where we can use formulas rather than the Pythagorean theorem to find missing sides. It would be great if we could do that for any triangle, no matter what its angles are. If you give me its angles and one of the sides, it would be great if there was formulas I could use to find the other two without the Pythagorean theorem. And so we are going to generalize those. And to do that, these are the labels we will use. So in each problem, I will tell you to use a certain angle, usually denoted by this Greek letter theta on a triangle, and then to label your sides opposite, adjacent, and hypotenuse. And again, you don't really need to write this down because that is going to be explained in this picture right here. So for example, if I say angle A here is theta, the angle that we're going to use for this problem, I'm going to label my sides opposite, adjacent, and hypotenuse, which we'll usually abbreviate as OPP, ADJ, and HYP. And hopefully these angles make sense, or these labels make sense to you, why we label them the way they do. This side here, little a, we call the opposite side because it is opposite the angle, right? This leg over here, we call the adjacent side because it is next to the angle. And this side over here, we call the hypotenuse because it's the hypotenuse. It's opposite the 90-degree angle. Okay, So from now on, when I give you a triangle and I'll say label it for angle A or label it for angle B, or there might be a little theta in the diagram, label it for theta. You're going to use these three labels. You're going to tell me which is the opposite, which is the adjacent, and which is the hypotenuse. Again, that's a very doable task to do, but really only if you have like a picture to refer to, right? If you don't have this picture in your notes, I'll say it, you could probably figure it out this time. If I said, label your triangle opposite, you probably could guess which one is the opposite. But the issue is eventually the prompt will just be solve for X, and they're not going to say the first thing you have to do is label. These are the labels you have to use. Go forth and prosper. All right, does anyone need more time to write? Doesn't a little bit? Okay. Isn't math just great? Like there's just like these set things that you do, and if you follow the steps, then you get the right answer. Right? No? I always like whenever I was taking science classes, I don't know about you, but when we were doing the labs, I would try to do the labs following the steps and procedures, but then every once in a while, like it would come out wrong. Like the teacher's like, no, that's not supposed to be what happens. Right? Usually because of human error on my part and messing things up. But I know like we were measuring for physics, like the acceleration due to gravity from dropping a ball. And every time I did the lab, I would get the wrong answer. They're like, no, that's not the right answer. You're messing up. And I'm like, I'm following your steps, but I don't get it right. Math, that's not, if you follow the steps, you're forced to get it right. It's impossible not to. I suppose you could still have human error if you mess up a step, but not like you can in physics where it'd be like, okay, well, it turns out that for today, based on our location, the acceleration due to gravity, is a tenth of a decimal off. Or we're using imprecise tools to measure this, so you're never going to get the exactly right answer. Here we can get the exactly right answer. Or an English paper where I can say, all right, here's the like process you follow, but All right, yay? Good. All right, so now let's have you try this. So given this angle, I should have used theta again, but angle alpha. Given this angle right here, label the sides of the triangle. So tell me which side is the opposite, which is the adjacent, and which is the hypotenuse. Okay? I'll give you 3 minutes, which is probably more than you need. But Okay, I'm gonna walk around now. If you have nothing done, stop me as I walk by and I'll walk you through step by step how to do this. Don't just suffer in silence. Angle, that's the Greek letter alpha. That's sometimes used instead of theta. But yeah, it's just this angle. So tell me which side is opposite that angle, which one's adjacent to that angle, and then what's the hypotenuse. Got it? Got it? Very good. Question. Yay. Got it? Got it? That's so dark. How do you see? Yeah. Okay. B looks like there's an 8. Which one is opposite? 8, 15%. A little bit. We'll do more of these. In fact, really, I think half the lesson is doing this. Okay, so what I've seen so far is really impressive. I think we're picking this up. So which was the opposite? 8. Because again, it's a cross. It's not touching the angle. Adjacent means next to. So which side is next to A or alpha? Okay, this is where people get trapped up because both 17 and 15 are touching A, right, or alpha. But it can't be 17 because what's 17? 17 has to be the hypotenuse. So usually what I'll tell people is label the hypotenuse first. That way you don't get them switched. 15 is the leg that is adjacent or next to. All right. Make sense? Okay. So what is next? Do I want to do this right now? Or maybe I'd rather prefer to do a homework one really quick. Yeah, let's do a homework one real quick. Let's do number 9 on the homework. Okay, so if you are doing this remotely digitally, pull up the homework for 6.4 and go to number 9 and try that one. Anyone want a paper copy? Copy? Copy one? Question? All right, so let me pull that up. 6.4, number 9. What?
What is sin, cause, and pain?
Yeah, I haven't got there yet. That's literally the next slide. So I'm glad you're asking about that. That's the formulas. So this is the labeling. Next thing is the formulas. But for number 9, if we say that this angle 37 is theta, which side is opposite the 37 degrees? What is the adjacent leg to the 37 degrees? And which of these is the hypotenuse? I'll give you a minute more. I am hungry. That's wrong. Okay, so can anyone tell me B, or let's say, let's start with AB. AB here, this side right here. Is that the opposite, adjacent, or hypotenuse? That's the hypotenuse. Why is it the hypotenuse? It's the opposite of the 90. So you could, if you're doing this in Kami, you could just write your answer like that. If you are a fan of Google Docs, just type in AB equals height. All right, BC right here, is that opposite or adjacent to our angle A? It is opposite. That's right, because again, it's across, it is not touching the angle. So we could write, again, in Google Docs, we could say BC is the OPP, which means AC has to be the adjacent. This one is this leg is touching our angle A, so it is the adjacent. And again, if you're doing this in Google Doc, you could write that AC equals ADJ. Okay. Do we want to do number 10 too? No, I'll let you do number 10. Number 10 is a similar problem that you could do right now pretty quick with about labeling. The rest of these will require you to label, but we need to do more notes before we can do that. So I think I'm going to give you those notes and we'll practice some more, just in case, you want to. Okay. So I think we are pretty comfortable with the labeling part. The second thing we do then is to use a formula, right? We label our triangle and then we use a formula. These are the formulas that we're going to use for any triangle. There's 3 of them, and they are called your trigonometric ratios. So again, this you don't have to write. You can write if you would like. It is an explanation of this next picture. This next picture is important to write. So you could probably abbreviate this some. Actually, yeah, you probably really just need this. Okay, so a trigonometric ratio tells you a formula that will relate 2 sides of your right triangle based on the angle. There are 3 ratios then, because there's 3 possible combinations of sides. There's sine, cosine, and tangent. Sine is usually abbreviated SIN, and the sine of an angle A will tell you the ratio between the opposite side and the hypotenuse. So the sine of A is equal to opposite over hypotenuse. Or in our case, for this example, A over C. Cosine is abbreviated COS, and the cosine of an angle will tell you how the adjacent relates to the hypotenuse, or it'll be equal to, in our case, B over C. And then the tangent is the opposite over adjacent, and it's abbreviated as TAN. So for this example, that would be A over B. This is a big deal right here. This right here is a super big deal. If you can understand this part of these notes, you raise your ACT score like multiple points, because they always ask you about these trigonometric formulas on the ACT. In fact, they usually ask you about it multiple times. So this is just like unlocking questions on the ACT, which would have been impossible to do before. And now you could do them again with relative ease. You got to identify that you have a right triangle, label the sides appropriately, and then use your formulas. What can make this kind of tough on the ACT is they do expect you to have these labels memorized. And they do expect you to have these formulas memorized. There's a trick to memorizing them, though. There's a phrase that you can say that has all the formulas in it. And it's so, ka, to, ah. This phrase, I've had people in this class at the beginning of every quiz, test, homework, they just write that on the top. SOHCAHTOA. It has all the formulas you need. The sine is the opposite over hypotenuse, SOH. Cosine is the adjacent over hypotenuse, CAH. And tangent is opposite over adjacent, TOA. So, ka, to, wa. So, ka, to, so, ka, to, so, ka, to. I almost thought about naming Lincoln, my firstborn, SOHCAHTOA. The wife vetoed that. Pretty hard. That'd be a great name, though. He would never forget his trig ratios. It's his name, SOHCAHTOA. Right, and again, I will tell you right now for 6.4, we're going to stop at labeling and then setting up the formulas. We won't even solve anything at this point. We're just going to label and set up. So the homework will seem kind of weird because you'll feel like, I don't know, you'll feel like it's unfinished, that there's more to do, like you need to solve it or something. You don't. We're just labeling, setting up. That's it. I will give you a preview of what's to come, though. Once you have your labels and you've plugged in your parts to the formula, what you'll find then is you'll know 2 out of the 3 things in that formula. And so you can use it to find the remaining side, which is something really important. So for example, if I was to go out and ask you to measure the height of that tree that's outside our window right now, that would be impossible to measure directly, right? You can't take a tape measure and hold it at the base of the tree and bring it all the way up to the top. So instead, what you do is we let this be the tree, right? That is a beautifully drawn tree, okay? And then we walk away from the tree and we measure along the ground how far we walked. So let's say we walked 10 feet from the tree. And then we measure the angle from us to the top of the tree using a protractor. Really a clinometer, which is a protractor with a paper clip attached to it. And you measure and you see the angle. And then you can use the tangent of your angle given the adjacent side so that you would only have A left in this formula to find. And so if you multiply by B to solve it for A, we can find the height of the tree. Which again is really a powerful thing that you could do. It's impossible to measure that tree otherwise, right? You only way to do it feasibly is to use trigonometry. Like a really big deal. Okay. Does anyone need more time to write? Can we fit? Oh, okay, let's finish on one example and we'll do more of these on Monday next week. So for example, if I want to write my three formulas for angle A, again, there are two steps. First step is to label. So let's do this triangle first. If angle A is theta, the angle we care about, oh, we already did this triangle, didn't we? Right, 8, 15, 17. This is the opposite. This was the adjacent. And this was the hypotenuse. So then what we would write then, again, we're only going to use the formulas to set up. We aren't actually going to solve anything yet. We're just going to practice how the formulas work. So what we would write then is that the sine of angle A is the opposite over the hypotenuse. So for our problem then, the sine of angle A would be 8 over 17. In future classes, I will show you how to use this formula to find out what angle A is. But again, we're not going to do that now. Just setting up, this is done. I have written the ratio for sine. The cosine of angle A, according to my notes, is the adjacent over the hypotenuse. So if I plug in, the cosine of angle A would be, what's my adjacent side? 15 over my hypotenuse, 17. Again, I'm just writing the formula, done. Not doing anything more to it. Tangent of angle A is opposite over adjacent. TOA. So the tangent of angle A would be 8 over 15. Again, not doing anything more to it. That's all you're doing for the rest of the homework. Let's find the sine, cosine, tangent. You're just writing a fraction, done. We'll do more of these on Monday. Homework is not due Monday, it's due Wednesday. Once you have a picture of this or written it down at your notes, you can pack up. I'll say it again, just in case you hear. No, this homework is not due Monday. No homework due Monday. Homework's due Wednesday. We'll do more examples of this on Monday. Have a good day, everybody. See you Monday. Eat your vegetables. Bye.